Now we are going to work on the example with the help of random forest algorithm, and here also we are using the iris dataset. Here you can see that iris is a family of flower which contains three types of flower, that is Setsoa, versicolor and virginica. And the problem is that we have some features of the flower, and based on those features we have to identify which flowers belong to which category among the three. Now the solution is that we know now this type of problem belongs to classification problems. We can solve this using supervised machine learning classification algorithm. But now we are doing it with the random forest classification algorithm on iris dataset. So here you can see that firstly I have imported some libraries which are required, that is NumPy, Pandas, sklearn and sklearn matrices I have also imported for calculating the accuracy score, and dataset I have used to load the iris dataset which is there. In the sklearn documentation you can see that a dataset has been already created. Next what we need to do is we need to load the dataset. So for that I have to write like this: iris data equals to load iris and then I have to write like this to change it into a data frame. Iris equals to pd dot data frame of iris data dot data. So this is how I've converted, and next what I have to do is I have to check the shape. So how can I check the shape of the dataset which is there? I have to simply write like this: print iris dot shape. Okay, and next if I want to print the first 5 samples, then for that we use the head method. So here you can see that the shape is 150,4. That means there are actually 4 kind of classifications which are given, or let's say 4 features which are, that are sepal length, sepal width, petal length and petal width. And there are 150 samples which have been analyzed, and this is the length which is there in centimeters. And the dataset is also being printed. The first 5 samples have been printed. Now we loaded our dataset, that is for iris flower. You can download the dataset also, so you can simply import it like that. We have done it. Next what we have to do is we have to print the categories, that what are the actually categories, or what are the actual features, or what are the classifications which are done. So we have seen that there are 3 classifications which are there, and also we will print the feature name also. That means this 0, 1, 2, what is this? Actually we want to know. Right now I've told you that this is sepal and petal length, but if I want to print, then how can we do that? So we have to simply write in print statement like this: iris data dot target names and print iris data dot feature name. So here you can see that the target names or the class which have been classified are Setsoa, versicolor and virginica, and the features which are there, that is sepal length, sepal width, petal length and petal width, the 4 features which are there. Next what we have to do is we have known the features also, and now we will print the sample on the basis of the target values, and we will pass them in x and y. X will be having the values and y will be having the targets. So for that you have to write like this: x equals to iris dot values and here you have to pass the values like this: 0:4, and in y you will be having the target values. Then you will print the x 0 to 5, and with respect to that you're going to print the y also. So here you can see that all the features or the values have been also printed, the first 5, and also the y, the target value, have been printed. Now 0, 1, 2 are actually the categories which have been given. 0 is given to Setsoa, 1 is given to versicolor, and 3 is given to virginica. And there are 4 features whose values are changing when the category of flower is changing according to that. Next, we will split our data set into the train set and the test set, so that we can make a classifier and then implement the random forest algorithm. So these steps we have also repeated while we are discussing the example of classification also, if you notice. So we will write here like x train, x test, comma y train, and y test. Then we are going to use the train test split function, and here we're going to pass the values x comma y, the test size that I'm giving here as 0.3. That means 30% data I'm using for testing and the rest 70 I'm using for the machine to train. And then we will use here random state, and you can give any value to random state here. Next, what you have to do is, now you have to define the random forest classifier and perform the training on the x train and y train. That we will do with the help of fit. So here I am writing a variable that is classifier of r, that can be said as random forest classifier, equals to, then you have to check this random forest classifier and give a random state equals to 100, and then you have to fit the data to your model. And what data you're fitting? You're fitting the x train comma y train. So now here are some keywords here, you can see that. So firstly the n estimators here, which is there, here you can see that the n estimators. So this n estimators is actually parameter defines the number of trees in the random forest. That means we have studied about on the basis of several decision tree a random forest is created. So there are actually 100 decision trees which are there. Criteria Gini is actually calculated in Python sklearn with the help of sklearn. In short, to make decision in the decision tree, we have to calculate the Gini index and then join together these three to form a random forest. Random state can be any integer. The reason behind defining the random state parameter is to initialize a random number generator which ensure that the split you generate are reproducible. If you do not define random state, then what happens is that a new random value is generated and the train and test data set would have different values at each the time. Next, we also have a bootstrap. Here you can see that this bootstrap equals to true. That means it is done to create several subsets of data for training sample and choosing it randomly. Next, we are going to make the prediction, and in prediction we use a variable named yPredict equals to the classifier dot predict the values which are there in x test, and then simply print the yPredict. So here you can see that an array is generated. Here we have used our trained model to make the prediction on the data set. Basically, we are checking how our model is working. Testing is also a part of the training of more data. We will feed into our model and it will learn more like a human being. Testing a model is just like a revision of the samples. Next, what we are going to do? We are going to check the accuracy of our model. That what is the accuracy? So for that, we use like this print accuracy, and this we use the accuracy score. So I'll write here accuracy score, and we always calculate the accuracy score in the y test, that what is there in the test set we have given and what is the predicted set. And I'm storing it in a NumPy array. And here we have printed, and next what is the CM? CM is actually the confusion matrix which we are creating, so that I am using a NumPy array for it. And that is, I'm calling here confusion matrix. And that will be also printed on the basis of y test comma y predict. And lastly print this CM. And as I execute this particular cell, here you can see that accuracy is also printed, that we can say there's 95%, and which is a good accuracy, means our model is predicting only 5% wrong prediction about a category of flower. And about this confusion matrix, the diagonal elements or the diagonal position which are there, that means the right predictions, and rest are the wrong prediction. Now let us check for a prediction also. For example, if we are using this particular classifier dot predict, and then we have to give the parameters which are there. If there are 4 parameters, then you have to give the 4 parameters only. For example, here I am giving these as the values for the petal length, petal width, and sepal length, sepal width set of flower. Then here you can see that it is displaying me that it belongs to the array of 2. That means it belongs to the Virginica, which we have 3 classifier of the classes 0, 1, 2 according to the set SOA, versicolor, and Virginica, so it belongs to Virginica. So this is all about the random forest algorithm on the iris dataset. You do not have to worry about the code. It is mentioned in our website also, and the link will be given to you in the video description.